Hi, and welcome to Säkerhetspodcasten, live-ish here at SecT.
Yes, sir.
We just grabbed Mohammed Aldoub off the stage.
Hello.
Where he talked about AWS security, right?
Yes.
Yeah. So can you tell us more about your talk?
So my talk was about attacking AWS security, especially in terms of, let's say actually both, in terms of exploitation and post-exploitation. So how you can get the initial access and how you can utilize that initial access to get somewhere else. My talk, concentrated on how the traditional model applies to AWS, how the regular web application vulnerabilities apply to AWS, whether or not they can make things worse or better. So as first thing we discussed, which is of most importance, is how the AWS environment in terms of security differs from the regular enterprise environment we usually come from. We discussed the shared responsibility model of AWS, which means that Amazon will handle some stuff for you. So, for example, you don't have to care about hardware, destruction of devices, data center security, cameras. You don't have to take care about, let's say, low-level attacks on networking, for example, ARP spoofing. But you do have to take more care than before on your own customer data and your own application security, because now you're not running inside your own data center. So whatever physical security helped you before, it's now running on the cloud, and you have neighbors on the cloud, for example. So you have to really understand how the model differs for the better things and the worst things in terms of security.
Yeah, go ahead. Yeah, what would you say are a lot of companies are moving to a cloud, and especially AWS. What do you say are the biggest differences from both an attacker and perhaps a defender perspective? What stuff are harder, and what is better in the cloud environment from a security perspective?
Okay, so from security, let's talk about the attacker. In Amazon, running attacks against lower levels of the stack, for example, networking, become much more difficult. As we said, for example, so running man-in-the-middle attacks is more difficult. You have to use Amazon's own features for that. For example, VPC, virtual private cloud traffic mirroring. So you can't just plug your own hardware or plug your own, for example, tab in the network. So as an attacker, you have to actually go up the stack. So you have to learn how to use the Amazon API to make your attacks automated. You have to put more focus on understanding the issues of Amazon itself. For example, the Amazon permission system, the Amazon services, and how the behavior and the configuration of Amazon services, so that you can utilize that. Because the problem, and that's the same thing for both attackers and defenders, is that when you go to the cloud, now you have lots more things to understand in terms of the environment itself. So you have to understand the Amazon, ecosystem, the APIs, the permissions, all the features inside it, how they interact with each other. And then you can understand whether or not you have to shift or make some changes to a threat model. As an attacker, you also have to learn how Amazon works so that you can utilize or abuse all of these missed assumptions by the developers and the defenders.
Yeah, because that's a common problem, no? Like, since Amazon's ecosystem is currently changing a lot, evolving, services are attached, features are added in every module or every service there is, right?
I'll give an example.
Yeah.
When Amazon adds a new service, they don't enable CloudTrail for it. CloudTrail is the log system inside Amazon Cloud, which is append only, so you can't delete from it. But the thing is, when Amazon, usually when they add a new service, they don't add CloudTrail logging features to it immediately. So if you use it, or if an attacker initializes it on your account, you really have difficulty in understanding what happened there because it doesn't have logs yet. That's one example. Another example is that by default, CloudTrail, the logging, as we said, system for Amazon, is not enabled on all regions. So suppose you have your infrastructure running in, for example, United States in California, in Amazon's region in California, and you enable CloudTrail for that, and you don't enable CloudTrail for all of Amazon regions. Someone could, if they compromise your account, to make things more stealthy, they could go and create some infrastructure in Amazon's region in Japan, for example. And then, because you don't have CloudTrail enabled there, you wouldn't know what's going on what's happened and what was done. was created in your own environment there in that region. So, for example, one of the most important recommendations is to enable CloudTrail everywhere. But that's not the default, which is really interesting. In my opinion, I think Amazon should have enabled CloudTrail by default for all regions, because or at least if I start any service there, CloudTrail should be initiated as well.
It should be an event handler or something telling you that but there is actually open source projects or AMIs that you can install that helps you track changes in your infrastructure.
Yeah, there are lots of tools for AWS, either like tools you can run yourself, or you can install in the cloud. So what you said, for example, the AMI, which means the AMI is the Amazon machine image, which means that it's an image for a server that you run. For example, you can create a Nessus appliance in the cloud. So you create an image for it, and then you can just create servers of that Nessus image to do the scanning, for example. So there are lots of security vendors. Usually in the old days, you had to buy the box, right, with the hardware. Then they sold for you virtual images, for example, for VMware, right? So that you can install on the ESXi. In the cloud, they created AMIs which you can actually instantiate in your account to gain access to these security tools. So that's one thing, for example, that you can utilize inside Amazon. So some of the popular tools that we use have a place inside Amazon. We can use them. But as we said, still, there's a lot of focus on the homework that the defender has to do inside Amazon's own special environment and their own ecosystem. I've seen many times organizations use Amazon just like they use the regular environment. So, for example, the EC2 instance, they use it exactly like a regular server. So they log in daily to it, give it updates and all of that. Okay, that's fine, but that's not the power of the cloud. They say treat your servers in the cloud like cats and not like pets. So what they mean is that don't give any server special treatment. Use automation to manage all the servers, to handle all the updates. Because when time goes on, you'll see that your configuration will begin to diverge, right? So it will become inconsistent. Yeah. The cloud can help you with that if you use the cloud's features, let's say the cloud native tools.
Yeah, and the ecosystem that's intended for these services that you're actually using. Exactly. Yeah. Let's touch base on the IAM module. What's your take on that? Do you think that's that it's easy as a developer or a sysadmin to do it the right way?
No, it's complex.
Yeah, right? Super complex.
So I'm not going to sit here and tell you that everything is easy. No, some things are really complex. Some things,
especially when you're talking about the evolving of the ecosystem, when everything needs to intertwine. And
Amazon now has almost 6,000 permissions inside IAM. Many of them don't allow customization, so they allow only wildcard actions on those services. So that's a really difficult thing for defenders to manage, and that's a really good benefit for attackers, because when permissions are really difficult to understand by developers, they tend to give out, let's say, excessive
overly permission.
So that's a really big problem. And another problem I've seen that defenders usually don't monitor and manage the IAM permissions. So they don't put, for example, some of them do the basic stuff like alert if any user gets added. That's cool, but do you alert if there's a new key that was added? Do you alert if there's a policy that was added? So some things are really complex, or let's say require your own customization because Amazon doesn't allow it, or doesn't provide it by default. And then things we didn't have in the past. No. So these are new things that the developers or defenders have to get used to. So sometimes going to the cloud could be a lot more work than the regular enterprise.
Yeah, for sure.
I would say so. I would say like a lot of enterprises are running to the cloud to make it easier to run your backends. But I would say it's pretty
far from the truth, because it's a more complex environment, more interoperable environment, and as you're mentioning the AVS profiles and all the intertwinements in there, we have like reverse blacklisting functions like not actions, which sort of is not action in conjunction with allow. Sort of means if you haven't explicitly said this is not allowed, then it's allowed.
Yeah, the whitelist versus blacklist approach.
It's really
blacklist.
Twisting your mind.
The thing is, with Amazon, with organizations moving to Amazon, they think they want to have less problems. In the end, you're not going to have less problems. We just hope that we get better problems. So there's a
different kind of problems.
Yeah.
Good,
So
good way of putting it.
if there's an organization that has lots of developers, moving to the cloud could be a really good choice, given they actually give attention to the AWS environment ecosystem itself. So they don't just use it just like any other regular.
But it's more or less like, don't you think it's more or less of a maturity level as well? If you have a good and solid DevOps pipeline from the get-go, like you're building everything in a more or less defined pipeline and sort of use cloud native stuff like Terraform or some kind of, more or less streamlined and customizable pipeline, and then you will be more or less okay. But it demands that you know what you're doing
exactly
in every step. Exactly. So that's why it's so easy to mess up. So configuration issues, in my opinion, it's the new thing. Like we talked about SSRF and the metadata layers. That's just part of it. Then you have this complex feature set that nobody really understands and are really, really prone to be misconfigured.
Yeah, the problem with the automation should be good, right? It's a positive word. When you hear automation,
of course.
The problem with the automation, if you automate your wrong stuff, now you have an automated problem. So
that's good way to put it.
It's really tricky to understand the difference. I'll give an example. Now, Terraform versus Chef. Which one do you use? Chef, for example, is good to manage running environments that are already divergent, for example, because it runs based on SSH keys, for example, that it uses to manage the servers. Terraform, on the other hand, is best used to create an environment instead of managing a running one that's already diverged or changed, for example. So, really, if you have like thousands of resources to manage, then you're going to, these small differences will manifest themselves at a much greater or grander scale. That's why automation is really tricky if you automate the bad stuff or the wrong stuff, because now you have 10,000 times the problem because you automated the problem itself.
Yep.
So this was a lot about post-exploitation, I guess, mostly. How do you get typically, what's the easiest way to get like the first foothold, the first access keys?
Usually, if you see a practice of how most organizations are attacking the cloud, it's usually through regular web vulnerabilities. The thing is, many times these regular web vulnerabilities manifest their severity differently in the cloud. I'll give an example. Suppose I have a regular enterprise that runs a Windows database server, and I have a SQL injection. Usually, I could run my own SQL code on that Windows database server, right? SQL server. But then I can use, for example, the XP command shell procedure to run commands on that server itself and maybe compromise that server. And then from that server, go on to the rest of the data center, right? Now, in the cloud, suppose a cloud customer uses RDS, Amazon's distributed database service.
Yeah.
When you have a SQL injection on RDS, you're usually constrained to only the data itself. So you can't compromise that server because it's managed by Amazon. And you can't use it to, let's say, propagate further through the environment as easy as if it was a regular enterprise. So this means that, in my opinion, regular SQL injection in regular enterprises is maybe more dangerous than in AWS environments. Because
you could reach, though, like snapshots or something.
No, let's see the other way around. SSRF. As I said in the talk, nobody cared about SSRF before. They even called it Open Redirect. Like it's a lame name. Doesn't really capture the severity of it. So it's an Open Redirect. Yeah, maybe you can, if you can guess an internal service, you can call it. Maybe that's it. So inside data centers, regular enterprise, they didn't care much about SSRF. It usually was reported as low. Some people don't even report it. They don't even see the need for it. I've seen that. Now, in the cloud, as we demonstrated in the talk, SSRF could be the most dangerous vulnerability. And if you disagree with that, fine, but ask Capital One how it played out for them. For example.
No, we have a lot of breaches of those as well. Have you looked anything of the clustering, the Kubernetes cluster in AWS, the EKS?
Amazon's, let's say, containers and Kubernetes services, ACS and AKS, have lots of issues that need to be understood correctly, because now we have the complexity of Kubernetes, then under that the complexity of AWS itself. But it's not my specialization. No. There is a tool released by Rhino Security Labs for the container attacks on AWS.
Yeah.
So someone who's interested in both AWS and containers / Kubernetes could check into that tool. I think it's called ECCAT or something like that. I don't remember the name exactly.
I think something like that. And then you have Pacu as well for post-exploitation.
Exactly.
And your tool. We haven't talked about that.
Yeah, Bark.
Yeah,
Bark means, as I said in the talk, means lightning in Arabic. You know, cloud and lightning, all of that.
Ah.
Yeah.
Now I'll get it.
Bark is a post-exploitation attack framework. So it assumes that you already have a key.
You have an access key in some context.
Yeah. And it assumes that it has privileges to do whatever feature you want to use inside Bark. So Bark allows you to attack EC2 instances without having access to the SSH key. As we've seen in the...
And in enumerating features as well.
Yes.
It's really neat because it takes a long time to go through every region, right?
Enumerating the attack surface is very important because sometimes you miss something the defenders missed. You see something the defenders missed, for example.
Sure.
And even as a consultant, I do it with my clients a lot because it could be the case that someone compromised my client and they created an instance in, for example, Japan or Sao Paulo and the different regions of Amazon.
Yeah, I guess you can use it as like an audit tool as well.
Yeah, exactly. It actually dumps the Lambda environmental variables, which usually contain like password secrets. So environmental variables are a way for a developer to send arguments to the Lambda function because the Lambda function cannot be invoked the regular way.
Nope.
So
it only lives for a few seconds.
Exactly. That's how you can, for example, send, let's say, arguments or parameters to it. Bark also dumps both the secrets manager and the parameter store of Amazon, which people usually use to store credentials, keys, parameters that other services can use. For example, suppose I have an application and I don't want to put the database password in a plain text in the config file. So I can dynamically call Amazon's secret manager at runtime to obtain the password credentials so that it's not now living in the configuration file itself. So it's a really good good use case for secrets manager to not have your secrets in plain text in source code. So you use that feature of Amazon. So a Bark can also, of course, give it enough permissions for the API key that you have somehow obtained before to dump these secrets manager inside
KMS and parameter store.
Secrets manager parameter store. The way Bark uses runs the attacks against EC2 instances is using the systems manager feature inside Amazon. Systems manager feature allows you to run your own PowerShell or Bash shell scripts on the EC2 instances. And this would come from inside Amazon. So a defender looking for regular connections coming from outside will miss this definitely. And it is logged actually both input and output inside System Manager. So System Manager logs the input and the output of all these commands. But unless the defender knows about System Manager, they're going to miss it. So that's the point. That's why you have to understand the AWS ecosystem.
Yeah. That's really good summary. Yeah.
And to finish this off, I would like to thank you for enlightening me of one of the new services of Amazon, the satellite ground station.
That's
what was that about?
Amazon services are so various. So the really widespread, unbelievable things: video transcoding, servers, satellite ground stations. They also have a service called Mechanical Turk. It's where you hire, cheap labor to do things for you.
Yeah, just pressing buttons.
Unbelievable. Amazon has lots of really interesting services. Whether bad or good, that depends on your interpretation. Well, really, that's why it's difficult to secure.
So, if our listeners would like to tune in on your channel, where do you have a Twitter handle? Or?
Yes, I do have a Twitter handle. It's Volnet, VOULNET.
Yep.
Yeah, I think it was a GitHub repo with the same name, right?
Yes, with the same name. Also, my GitHub.
So now you know where to go.
Yeah,
thank you.
Thank you, Mohammed. Really good talk.
Yeah,
thank you.
Yeah, thank you. Good.
Thank you very much.
Sweet.